Hi. So in this video, we are going to be looking at probability and what we mean by probability. Probability just simply means possibility in any outcome, the possibility of an event to occur. So here we are going to be looking at the basic definition of these approaches that we can use when we are working with probability. The first one here we have the classical approach, we have the relative, frequency, and subjective approach. But I may not be going in depth in all of those approaches, but how to understand probability scenarios and how to address them respectively. So yeah, based on what we have here, it says by the classical approach, the probability if these possible element outcome are favorable to event A, possible outcome are included in the sample space, and all element outcome are equally likely and mutually exclusive, then the probability that event A will occur is A out of the sample space. So what this is trying to say is that if I have, let's say, about 5 red balls and I have 3 blue balls, and I also at the same time have 3 purple. So this here all sum up to 11 balls. So what that is trying to tell us is that when we have probability of this kind, then what is that thing that we have to do? Looking at this, if I say, okay, what is the probability of A? Let's say the first question says find the probability of getting a red ball. So the probability will just be what do we have as the number of red balls here? We have 1, 2, 3, 4, 5. So it's going to be the number of red balls, red, over the number of total, or let's say sample space. So I will explain what we mean by sample space in as we proceed. So here the number of red balls that we have equals to 5, and the total balls that we have in everything is 11 balls. So here we have 5 over 11, which will now equate to the value, which is 0. Whatever that we have there. So yeah, that's the simple definition of the classical approach. That's what this is trying to denote here when it says the probability of A will be the number of occurrence that A has over the sample space. So like I said earlier, I said I will talk about what we understand by the sample space and outcome. So outcome is the possibility of something, that is the value that a particular event will occur, and the sample space is just like what we are actually working on, the number of what we are working on. So to explain that more briefly, I will say the sample space let's say we have population of 1,000 people. So these are 1,000 people. Population of 1,000 people, and as out of this 1,000 people, I can't start counting each and every one of them. So I just select some number of people at random. Let's say I selected 50 people at random. So this one here now will now give me my sample space here. So this 50 is my sample space, which means that particular one that I'm trying to work on at that moment, that is my sample space. So continuing with this, That is the sample space. So the event of me choosing, let's say for instance, I choose, let's say, this one while closing my eyes. What is the probability that that person that I choose will be a boy? The probability that that person will be a boy is that, okay, in the sample space we have both male and female, right? So the probability that that person will be a boy will be 1 out of the 2 chances, because we only have 2 chances in that case that the probability of someone will be a boy or a girl. So 1 out of those 2. But when we are talking about, let's say, another event such as football, these are balls, and I say, okay, probability of choosing a red ball, I will just have to count the number of balls that we have here. Let's say we have 5 balls out of 50. So I say 5 out of 50, that will equate to 1 over 10, which is the same as 0.1. So yeah, we have our probability to be taken. And one more thing that we should try to understand before we proceed also is that the probability of something to happen, let's say probability of A, will always be, let's say A will always be less than or equal to 1, and at the same time greater than or equal to 0. So what this is trying to say is that A cannot be, let's say, minus 2. It can never be negative, and it can never be greater than 1 that we have here. So what it's trying to say is the value of my A fall between 0 and 1. So the value of A fall between 0 and 1. It may be 0 0.1, 0 0.2. We can also have 0.5 that's evenly distributed, just like what we have in the case of selecting out of a gender base out of a population. And we can also have 1, which means that is the extreme part. There's no other case. So probability here also says that the possibility of something to occur it can be rather from 0 to 1. And looking at this from 0 to 1, by the time I try to convert this to percentage, it means from 0% to 100%. So our value still falls between this percentage. Now let's look at this example 1, what it says. So it says, in a well shuffled deck of cards which contain 4 aces and 48 other cards. So here we have how many cards in total? We have 4 here and we have 48 here, which means we have 52 in total. So the probability of an ace being obtained on a single draw is, so now here I have to first know how many cards are there. So to do that, what I'll just do is, okay, I'll say I have 52 as total, right? My sample space is equal to 52. Then for me to get an ace, it will be how many times ace occur. Ace occur in this deck of card 4 times, which means if I'm to find the probability of getting ace, it will be 4 out of 52. That will now give me the 1 over 13. So here the number of deck that we have, the number of cards in the deck that we have here is 52, which we use as our sample space here, and the number of time ace appear in that deck is 4. So breaking this down to their simplest form, we have 1 over 13, and this can also be converted to decimal, at which a will still be less than or equal to 1, and at the same time greater than or equal to 0. So the value of a will fall between this range. Yeah. So now let's look at this example 2. Before including coverage for certain type of dental problem in health insurance policy for employed adults, an insurance company wishes to determine the probability of occurrence of such problem so that the insurance rate can be set accordingly. Therefore, the statistician collects data for 10,000 adults in the appropriate age categories and find that 100 people have experienced the particular dental problem during the past year. So now the probability of occurrence is thus. So yeah, the number of data that they try to collect is 10,000, and as we can see in the number of realistically the population is greater than 10,000, right? So now we are told that only 10,000 data was collected. The statistician collects 10,000 data from adults, which means we are going to be having our sample space to be 10,000. Then, after having our sample space to be 10,000, we now say, okay, what is the probability of them having dental issue categories, and find that 100 people have experienced the particular dental problem. So the probability that that thing will happen, which is probability of success, that is P, we denote it as P, is that 100 will have it. So now this is just like giving it in figure. To get the actual percentage, we can now say, okay, the probability of that thing to happen, that is probability for us to get that someone will have a dental problem out of these 10,000 people, is 100 over 10,000, and 100 divided by 10,000 is the same as saying, okay, cancel this to 0, cancel this to, and I have 1 over 100, and that 1 over 100 is the same as saying the probability of finding out that these people, someone will have a dental issue, is 0.01. So as you can see, the value that we have here is probably less than 1 and greater than 0, which means this is the same as 1%. So among this population, 1% of them will surely have dental issue. So probability is very simple and straightforward when we actually know what to do and follow this simple process.